Hey everybody, so in this video we're going to talk more about radian and degree measure, and we're specifically going to talk about coterminal angles. Okay, so first let's define what a coterminal angle is. Okay. So we say that two angles are coterminal. If they share a coterminal side. In standard position specifically. Okay, so this may sound a little bit like you're defining it by just saying the name of it, but what it really means is when you look at two angles in standard position, their coterminal side falls in the same exact place, meaning that the angles look the same, even if their measures are not necessarily the same. So let's go ahead and look at how this could be possible. How are two different angles going to look the same? So we're going to start by just looking at the Cartesian plane, and we're just going to look at one really basic example, and then we'll look at how to find coterminal angles for lots of different angles. Okay, so first let's go ahead and look at the angle pi over 2, right? We talked about this angle a lot in the last lecture because it's actually the right angle. Okay, so if we draw this angle in standard position, remember the vertex is always at the origin, the initial side is always along the positive x-axis, and then pi over 2, like we said, is the right angle, so it's going to look like this, right? You can see it kind of wiggly drawn right here. Okay, really shade that in so you can see what I'm talking about. Then if we look at the angle negative 3 pi over 2. Hang on. I like to do this in a different color so we can see the difference here. Okay, so if we're looking at the angle negative 3 pi over 2, remember we're still going to start with our vertex here and our initial side along the positive x-axis. Then our negative angles are going to open downwards. So remember this is negative 1 pi over 2, negative 2 pi over 2, and negative 3 pi over 2. So even though the angle is completely different measure, opens the opposite direction, you can see that it falls with its terminal side along the exact same place. Okay, so these are one basic example of coterminal angles. All right. So let's go ahead and look at how, in general, we can find coterminal angles. Okay. So we're going to do an example. Okay, so we're going to look at two coterminal angles. One angle that is a positive coterminal angle, just meaning it's a coterminal angle whose measure is given as a positive number, and one negative coterminal angle, right? So that's meaning that it's opening up in a clockwise way or pointed down. Okay, so let's go ahead and look at our Cartesian plane, and then we'll look at our starting example here. Okay, so we're going to start with the angle 7 pi over 4. Okay, so the first thing I'm going to do is draw this angle in standard position. So I'm going to go ahead and put the vertex here, right? My initial side goes along the positive x-axis, and then remember that we're comparing it to all of these angles. So this is pi over 2, right? Or if we want it to have the same denominator as 7 pi over 4, this would be 2 pi over 4, right? So as our angle is opening counterclockwise, we can see that it's going to go past this. The flat angle is pi, or 4 pi over 4, so we know it's going to go past this as well because it's larger than that angle. And then this angle down here is 3 pi over 2, right, or 6 pi over 4. And because it's bigger than that, we're going to go past that angle as well. So do we go the whole way around? Well, one whole rotation is 2 pi, right, which would be the same as 8 pi over 4. So we can see that this is not going to make it the whole way around. We're going to fall somewhere here between 6 pi over 4 and 8 pi over 4, right? And our angle is opening this way. Okay. Now, if we look at how we could get a coterminal angle, one way to get a coterminal angle is just to start with your vertex here and your initial side along the positive x-axis, make one full rotation, and then go back to the exact same angle that you already talked about. Okay, so how would that look? We would have one full rotation, okay, and our angle. Now, if we change that into something more mathematical, right, one full rotation we know is 2 pi, and we know means plus, and then our angle, which is 7 pi over 4. Okay, so we're going to go ahead and add 2 pi to our original angle. So we're going to change this to have common denominators. Okay, and we'll see that our first coterminal angle is 15 pi over 4. Okay, so this is a positive coterminal angle, right, because the measure of this angle is a positive number. Now, if we want a negative coterminal angle, we're going to need to start here, right, and then actually go the opposite direction. So our angle is going to open up this way. Now you can see that we're not going to have to go very far, right? We're going to end here still. So our angle is going to start here and end here, right? So we can see that what we really have is our angle, okay, and then we're going to be going the opposite direction. So we're going to take away a full rotation. Okay, so our angle is 7 pi over 4. Okay, and when we subtract one full rotation, or 2 pi, okay, we can see that our negative coterminal angle is going to be negative pi over 4, right? This little angle right here. Okay, so to get positive coterminal angles, we're adding 2 pi, and to get negative coterminal angles, we're subtracting 2 pi. Okay. Let's do one more example of finding coterminal angles. Okay, so let's look at our second example here. So we're going to look at the angle negative 5 pi over 3. Okay, and again, we're going to start by drawing this angle in standard position. So let's look at our angle. Okay, so when we go to draw our angle, we're again going to compare it to the angles on the axes here. So this is 0, pi over 2. Okay, so if we want to make this have common denominators, we're going to change it into over 6. So this would be 3 pi over 6. And this would be negative 10 pi over 6. Now I can see that this is a negative angle. So instead of labeling these with the positive angles, that won't really help us, right? Because we want to compare it to other negative angles. So I'm going to start with negative pi over 2, right, which is negative 3 pi over 6. Then negative pi, or negative 6 pi over 6. Okay, now our angle is opening up counterclockwise, so I need to keep going past 3 pi over 6, past 6 pi over 6. Now this would be negative 3 pi over 2, right, or negative 9 pi over 6. So it's larger even than that. And then this would be negative 2 pi, or negative 12 pi over 6. Okay, so it's not as large as that, so we're between negative 9 pi over 6 and negative 12 pi over 6. So our angle is going to end up right here, right? It's opening up this way. Okay. Now to get our positive coterminal angle, just like we saw in the previous example, we're going to add 2 pi. Okay, and that represents us starting here, right, and opening up this way, just this little angle here. So that would give us negative 5 pi over 3 plus 6 pi over 3, right, or 1 pi over 3. Okay, so this is our positive coterminal angle. If we want a negative coterminal angle, because our angle is already negative, we're going to have to go the whole way around and then back around to our original angle. So this is going to be negative 2 pi, right? One full negative rotation, and our original angle, which was negative 5 pi over 3, right? So we're taking our original angle and we're subtracting 2 pi. Okay, making common denominators again. So this is going to give me negative 11 pi over 3. Okay, so there's our two coterminal angles, the positive one coming from adding 2 pi and the negative one coming from subtracting 2 pi. Okay. Again, make sure to take note if you have any questions about this, and I'll see you guys in class.